Good morning, class. We are looking at chapter 3, derivatives, and here's section 3.2, the derivatives as a function. We looked at the derivatives and rates of change, and now we're going to look at the derivatives as a function where f prime of x is limit of f of x plus h minus f of x over h as h approaches 0. The rest, after this section, we can use differentiation formulas. In these two sections, including this one, we are using definition. Reminding everyone that given y equals f of x and point A, comma f of a, the slope of a secant line PQ is the average rate of change, or simply delta y over delta x, rise over run y sub 2 minus y sub 1 over x sub 2 minus x sub 1. In this case, we can say f of x minus f of a over x minus a. In this case, we can say f of a plus h minus f of a over h. If this point, now we call it B, the y coordinate is f of B, it's f of B minus f of A over B minus A. All of them are the same, rise over run. The blue lines are the secant lines, and the red line is the tangent line, and we are trying to get to the red line, and to find the equation, we need to find the slope. In the case of the blue line, in each case, we have two pairs, we can find the slope. What about the tangent line? The tangent line is the limiting position of a secant line PQ as Q approaches P. A tangent line is a line that touches a curve at a specific point without crossing it. Slope of a tangent line, also known as instantaneous rate of change, then we can use this one, limit of f of x minus f of a over x minus a as x approaches a, or we can use this one. Normally this one we use as dq, difference quotient, the limit of f of a plus h minus f of a over h as h approaches 0. And here's various forms of lines: standard form, point slope, slope intercept form. And so if this point has coordinates a comma f of a, we can use the point slope y minus y1, that means y minus f of a, calls m is f prime of a, x minus x sub 1 is a. So you can memorize this, or just remember the point slope. You don't have to do that. And now the new stuff, 3.2, the derivative as a function. We have considered the derivative of a function f at a fixed number a, f prime of a, is limit of f of x minus f of a over x minus a as x approaches a, which is the same as the limit of f of a plus h minus f of a over h as h approaches u. If you recall, one of the last questions we did in the previous section, I kept it at a. And that's in essence moving towards this section. Here we change our point of view and let the number a vary. If we replace a in equation 1, this is equation 1, by a variable x, we obtain f prime of x equals limit of f of x plus h minus f of x over h as h approaches 0. If you want to use this, you keep it at a. When you're done, at the end, you change it to x. That can be done as well. Other notations. Given y equals f of x, then some common alternative notations for the derivative are as follows. F prime of x, y prime, dy dx, df dx, d dx of f of x, capital D of f of x, capital D sub x of f of x. The simple d, capital D, and d dx are called differentiation operators because they indicate the operation of differentiation, which is the process of calculating a derivative. We can rewrite the definition of derivative in Leibniz's notation. in the form dy dx is the limit of delta y delta x over delta x as delta x approaches 0. Definition. A function f is differentiable at a if f prime of a exists. It is differentiable on an open interval of a to b, or a to infinity, or negative infinity to a, or negative infinity to infinity, if it is differentiable at every number in the interval. We don't consider it at the endpoints. Find an equation of a tangent line to the graph of the function f of x equals square root of 3x plus 1 at x equals 8. This is just similar to what we did in the previous section. First and foremost, we need a pair. So if you plug in 8 here, you get 3 times 8. 24 and 1 is 25. Square root of that is 5. So the pair has coordinates 8, 5. The next thing is to calculate the slope. In the previous section, we calculated f prime of a, namely f prime of 8. Now we're going to calculate f prime of x, general format, and then we plug in 8. The reason is because what if they ask you to calculate the equation of a tangent line at x equals 8, at x equals 10, at x equals 2, several points? Then you're going to go through that with f prime of a several times. Now all you have to do find the differentiation function, the derivative function. So the limit as h approaches 0 of f of x plus h. Start with the formula, which makes square root of 3 times x plus h plus 1 minus f of x, just write this, over h. It's important to know if you plug in, of course, you get 0 over 0. And when you get 0 over 0, it is the 0 in the denominator, which is a troublemaker. We want to get rid of it. This is a minus b because we have a square root. We are going to multiply by its conjugate, a plus b, and we're going to divide by it. So a minus b times a plus b is a squared. So you're looking at a minus b times a plus b. The answer is a squared minus b squared. Each one comes out. Distribute and we get 3x plus 3h plus 1 minus 3x minus 1. Three x minus 3x cancel each other. Positive, negative 1 cancel each other. You're left with 3h in the numerator. Remember, we are hoping to get rid of the h in the denominator, and now we can. And we have this limit. Now, before we continue, I want to make a point. If you don't carry out the limit here and you want to simplify this expression to this expression, to this expression is fine. However, at this point, if you don't have the lim sign, this can't be dealt with. This is done. But with the lim sign, we are saying the limit as h approaches 0. Now we can replace the h with 0. Without this, you can't. When you replace the h with 0, this becomes identical to this. So the numerator remains. The denominator, we have 2 of these, 2 square root of 3x plus 1. This is f prime of x. This is the derivative function. This is not the slope of a tangent line. What is the slope of a tangent line? At 8, plug in 8. At 2, plug in 2. At 10, plug in 10. Whatever the number is. So this, in essence, represents infinitely many slopes of tangent lines. So what is f prime of it? Remember, we plugged in here, we got 5, right? So if you plug in here, you get 5. 2 times 5 is 10. 3 over 10 is your slope. So plug in 8, you get 25. Square root of 25 is 5. You get 3 over 10. And the pair, I showed you that it's 8, 5. Y minus y1 equals m times x minus x sub 1. So y minus 5 equals m 3 over 10 x minus 8. You distribute, you get 3/10 of x. And then when you multiply these two, you get negative 24 over 10 or negative 12 over 5. Please understand the product of these two. And you drop a common factor of 2. And now you have negative 5 here, everybody. We are going to move that make it plus 5. And 5 is 25 over 5. These two, they add up to 13 over 5. What is extremely important for everybody to know, this pair belongs to the original function. It must satisfy it, and that's how we got the 5. It also belongs to the tangent line, and it must satisfy that as well. If you plug in 8 times 3, 24 over 10 is 12 over 5 and 13, 25 over 5, which is 5. When it checks, that means this process was done without any mistakes. Doesn't say anything about the previous steps. Example 2, the graph of a function f is given in the figure. Use it to sketch the graph of the derivative f prime. And again, the emphasis is on sketching roughly. It doesn't have to be perfect, but you have to have a rough idea how it looks like. And to do so, we pay attention to the following important parts. Note, relative max and mean, that means peaks and valleys. F prime is 0. F prime is larger than 0 if is increasing. If you look at, for example, this part, looks like a line with a positive slope. F prime less than 0 if is decreasing. For example, this part looks like a line with a negative slope. So what do? We pay attention to important parts. First, A, you draw a tangent line. B, you draw a tangent line. C, you draw a tangent line. And for those 3 points, when the slope is 0, that means on the graph of y equals f prime of x, this A has the same x coordinate with the y being 0. This B, the same x coordinate with the y being 0. This point, the same x coordinate, y is being 0. How did they come up with that? I just want to make a point, and that is they drew a line, a tangent line, very carefully. They picked up 2 points and they calculated. What is the point of this? At x equals 5, the slope is 3/2. Therefore, there has to be a pair, okay, here somewhere. This is on the graph of f prime, which has the coordinates 5 and 3/2 or 1.5. Now, f prime is less than 0, f is decreasing. So if you look at this part, it's below the x-axis. It doesn't have to be exact. If you look at this part, it's also below the x-axis. However, at B becomes B prime 0, at C becomes C prime 0. So it's below the x-axis, but at some point has to come back up, looking like this. Okay. This part is increasing, and so is that part. And we are going to say if this part is increasing, it's above the x-axis. At A, we get A prime, which is 0. At B, we get B prime, which is 0. So it has to come back down to 0. This portion is also positive, so it goes up somehow, and it has to touch this point. If you look at the more precise graph, you see that it looks like that. Let me clean up my mess. And as you can see, A corresponds to A prime 0, B corresponds to B prime 0, C corresponds to C prime 0, and this pair corresponds to 5 and 3/2 or 1.5. This is decreasing, increasing, decreasing, increasing. Decreasing below the x-axis, increasing comes up and hits back to 0, decreasing below the x-axis, and then increasing above the x-axis. Very straightforward. We want to come up, okay, example 3, the graph of a function f is given, and we want to use it to sketch the graph of its derivative f prime. Anytime you have a line, calculate its slope. The slope, if it's 2, y equals 2, a horizontal line. The slope is 10, y equals 10. The slope is -5, y equals -5. It's a horizontal line. If the line itself is any horizontal line, the slope is 0, and it gives you the x-axis, which has the equation y equal to 0. So you are going to pick two pairs. This is clearly at 0, 0, and this is clearly at 1, 3. Please understand, the scale along the x and y, they don't have to be the same. So this is 1. Since this is 6, this must be 3. 3 minus 0, 1 minus 0, and m becomes 3. So all you have to do, draw the line y equals 3 as your answer, and you're done. What about this case? Let's look at easy points, peaks, and valleys. This is the peak, this is the valley. And those two correspond to those two. Okay, so you have peak, the slope is 0, valley, the same thing. So now this portion class is decreasing. That means below the x-axis. So it goes below the x-axis, but it has to come back to 0. This f is increasing, f prime is positive, is above the x-axis. This, the same thing, is above the x-axis. And putting them together, we get this one. What about this case? Again, this point, peak corresponds to 0 on f prime. This part is increasing. That means above the x-axis. This part is decreasing. That means below the x-axis. And if you put them together, you get the green graph representing f prime of x. How can a function fail to be differentiable? 3 ways. The figure illustrates the three possibilities: a corner or sharp corner, a discontinuity, a vertical tangent line. A corner or kink, the graph of f has no tangent line at this point. The left and right limits are different. So the limits are different on each side of A. If f is not continuous at A, for example here, then f is not differentiable at A. So at any discontinuity, for instance, a jump discontinuity, f fails to be differentiable. If you look at the definition of f prime at A, and then you see the limit must exist. And the limit of absolute value of f prime of x as x approaches A equals infinity, that means the graph of a function f of x has a vertical tangent line at the point A comma f of x. You remember vertical lines, you said the slope was undefined in the, when we were dealing with basic algebra. So if that I double f, that means if and only if, the limit of f prime of x as x approaches is either minus infinity or positive infinity. Both sides have the same result, meaning either infinity or negative infinity and not both. That's the idea. Cusp, when the limit of f prime of x, in this case as x approaches 0 from the right, is infinity, from the left is negative infinity. So it's similar to that. In this case, both sides are either infinity or negative infinity. In this case, one side is infinity, one side is negative infinity. So the definition of a cusp is that when the graph of the function becomes vertical and then virtually doubles back on itself, such pattern signals the presence of what is known as a vertical cusp in general. We say that the graph of f of x has a vertical cusp at a comma f of a if and only if the limit of f prime of x as x approaches a from the right is infinity, and the same limit as x approaches a from the left is negative infinity, or vice versa. Both sides do not have the same result. That's the idea, everybody. Both sides do not have the same result, and that's the key that we want to be careful of. Okay. So that's the basic difference between the two. Example 4, the graph of function f is given where and y the function is not differentiable. So when you look at this graph clearly, at x equals 0, we notice a discontinuity. Over here, at x equals 3, vertical tangent line. We're going to distinguish between a vertical tangent line and a sharp corner in a moment. Over here, clearly there is a discontinuity at x equals -1. Over here, sharp corner at x equals 2. To distinguish between a sharp corner and a vertical tangent line, notice this is a V shape. If it's upside down V shape, it's also the same. Whereas here seems to go up. Okay, so it's clearly not a V shape. Okay. Now, if you mix it up with a sharp corner, it's okay as long as we understand the concept. Example 5. The graph of a function f is given. Use it to sketch the graph of the derivative f prime. First, I want you to notice that we have 1, 2, 3, 4 line segments. Meaning, if you look at one of them, this one, and you think of it as a line, another line segment, okay? You can calculate the slope, and whatever the slope is, y equals that, which is a horizontal line, is the answer, you're done. And the same thing is true for each case. So let's throw in some numbers, assuming those are the coordinates of the endpoints. We can calculate the slope. Here would be 0 minus 1 over minus 1 minus negative 3, which results in negative 1/2. If the slope for this guy is negative 1/2, for this one must be positive 1/2. You can calculate it. You can easily see the slope if you go through the process is 1 here, whereas here is negative 1. So we have all those slopes. And again, just look at this piece. The answer is y equals negative 1/2, m equals negative 1/2, y equals negative 1/2. So for this portion, we draw a line segment, and that's the answer. And please understand, we have, again, if this was a line, not a line segment, then you would go with a horizontal line. But it stops here. We don't know what happens here at this point. We have a sharp corner, another sharp corner, another sharp corner. So this corresponds to a hole. So we have y equals 1 for this one, y equals negative 1 for this one, and y equals 1/2 for this one. For example, for this one, it just covers this much, and you have a hole here. Notice you have a hole here, and you have a hole here. Y equals negative 1 is for this one, and it goes from here to here. You have a hole, you have a hole. And for this one, starts from here and goes to the right. And again, look at this hole. Okay, this is how you graph it. 1, 2, 3, 4 line segments, 4 horizontal line segments. And in each case, the endpoints, these 3, okay, result in the following holes. We want to find the derivative of the functions. The next section, we do formulas that is very easy, but we are going to go with the definition, previous section as well as this section. So first you write the formula. F prime of x is limit of f of x plus h minus f of x over h as h approaches 0, and you apply that the limit as h approaches 0, f of x plus h is 5 times x plus h plus 1 minus f of x itself over h. All you have to do is simplify. Five x plus 5h plus 1 minus 5x minus 1. 5x and minus 5x cancel each other. 1 and negative 1 cancel each other. We are left with 5h. Remember, when you look at this limit, is the h in the denominator that is approaching 0 and creating a problem. We are hoping to get rid of it, and we do. A limit of 5 as h approaches 0, it's a constant. The answer is 5, and you're done. Part B. F of x is 2 over x. We write the definition. F prime of x is the limit of f of x plus h minus f of x over h as h approaches 0. So f prime of x is the limit as h approaches 0 of 2 over x plus h minus 2 over x. We multiply the top and the bottom by x plus h times x. And so what happens, remember, h is approaching 0, the denominator has a h. This is the one we are hoping to get rid of. You don't do anything to the denominator. As always, you keep it as a product. What happens to the numerator is that you multiply these two, x plus h cancels out, and you get 2x. And you multiply these two minus the x cancels out, 2 times x plus h. Now you're going to distribute. You get 2x minus 2x minus 2h. Clearly, 2x and minus 2x cancel each other. We get rid of the common h. Now, here's what I want you to pay attention to. If you didn't have a limit here, you were simplifying, it's fine. But over here, you must have the limit. It's extremely important to have it, because if you don't have a limit, there is nothing you can do to this expression. It is minus 2 over x times x plus h. When you have the limit as h approaches 0, now you replace the h with 0 and you get minus 2 over x squared. That's what you do. So that's pretty straightforward, everybody. All right, find the derivative of the function f of x equals 7x squared plus 4, and we start with the definition. Limit of f of x plus h minus f of x over h as h approaches 0. So f of x plus h would be 7 times, so the limit as h approaches 0, fraction bar, 7 times x plus h quantity squared plus 4 minus the parenthesis 7x squared plus 4 over h. X plus h squared is x squared plus 2xh plus h squared. Distribute to 7. You get 7x squared plus 14xh plus 7h squared plus 4 minus 7x squared minus 4. 7x squared and minus 7x squared cancel each other. 4 and negative 4 do the same. In the numerator, we are left with 14xh plus 7h squared. We factor out the h. We drop the h from the top and the bottom. Remember, if we go back to this one, the answer is 0 over 0. It's the 0 in the denominator that creates a problem, and that's why. And by the way, h is not equal to 0. H is approaching 0. So at this point, here's what you get now. Here's what the limit of 14x plus 7h as h approaches 0. If you didn't write the limit here and you said, I want to simplify this expression, I get to this point and I get to this point, it's fine. But over here, you must have the lim sign. And here's the reason. Because the limit as h approaches 0, now you can replace it. If you don't have that, 14x plus 7h remains at 14x plus 7h. With the limit, you replace it and you get 14x, and that's your final answer.